Welcome to today's topic, differentiation. When we talk about differentiation, it's about rate of change. You recall the work we did in Form 3 on instantaneous rate of change, where we were able to find gradient of a curve at a certain point. Now, we'll start with the gradient of function of a curve by using the first principle method. An example is that if we want to get gradient of a curve y equals to x squared at a general point xy, we know that a general point on the curve y equals to x squared will have coordinates of the form x and x squared. The gradient of the curve y equals to x squared at a general point xy can be established as below. That is, if we take a small change in x, say of h, it will give us a new point on the curve with coordinates x plus h. That is, our x2 becomes x plus h and x1 is x. Our y2 becomes x plus h squared, because this is our x and y is x squared, so you square this one to get the y. So the point Q will be x plus h and x plus h squared, while point P is x and x squared. And we know if we have a point P and a point Q, to find gradient is the change in y-axis, over the change in x-axis. So our change in y-axis will be our y2, which is x plus h squared, minus our y1, which was x squared, all over x plus h, which is our x2, minus x. Now we need to expand this. From the principle, we know that a plus b squared is equals to a squared plus 2ab plus b squared. You will expand that and get x squared plus 2xh plus h squared. Now we minus x squared. X squared and x squared, you subtract, you get 0. So we shall remain, and here x minus x goes, we remain with h. So we shall have 2xh plus h squared, 2xh plus x squared over h. Now we need to factorize the numerator. If we factorize the numerator, we shall have h into 2x plus h all over h. H and h cancels out, so we shall remain with 2x plus h. So remember that there was a change in x of h, and therefore as h reduces, as it goes to infinity, as it goes to 0, as it tends to 0, we shall substitute where we have an h with a 0, so we shall remain with 2x plus 0, which is 2x. So that is the differential function of y equals to x squared. It becomes 2x. That's the gradient. Example 2, given the graph y equals to x cubed, find the gradient function. Now, we need to know the coordinates. The coordinates, we said we need to have a small change in x, which was h. We use the same. A small change in x, which is h. And therefore, our first coordinate is x and x cubed. That is, x1 is x and x cubed. This one. And now, our x2 becomes x plus h, because there is a change that has occurred in x plus h. And x plus h, now we cube it, x plus h cubed. That becomes our y2. So we shall have this coordinate and this one when we have a small change in x, like I said, of h. And therefore, gradient we know is change in y over change in x, which is our x plus h cubed minus x cubed all over x plus h minus x. Now, we understand for us to x plus h cubed. To expand this, you need to remember what we call what we learned in Form 3 on binomial expansion for us to do it easy. So you need to know the coefficients. The coefficients, we have 1, 3, 3, and 1. And therefore, we use those coefficients and expand as we learned in form 3, and therefore x plus h cubed becomes x cubed plus 3x squared h plus 3x h squared plus h cubed. So now we minus the x cubed, minus x cubed all over x plus h minus x. So x plus h minus x and the x will, if you open the brackets, x minus x will be 0, so we remain with an h. And here we have x cubed, subtract x cubed, it goes, we remain with this one, 3x squared, so we shall have 3x squared h plus 3x h squared plus h cubed all over h. That is having cancelled x and x having cancelled out, and also x cubed and x cubed having cancelled out all over h. We factorize the numerator by having h as common. H is common here. You factorize, you look for a common here is h. H is common. H is common in all. So h is common being in outside. So h into 3x squared plus 3. That is h comes here. It cancelled out. It remains 3x squared. H here remains 1h, we shall have 3x, and h remains h squared, and that is what you get here into h. H and h cancels out, so we remain our differential or our gradient becomes 3x squared plus 3xh plus h squared. But remember, we said h tends to 0. As h tends to 0, so we shall have dy over dx, our gradient function, to be 3x squared, because you substitute h with a 0 here, h with a 0. 0 times everything is 0, and 0 squared is still 0, so we remain with 3x squared. So our dy dx, that is gradient function for y equals to x cubed, becomes 3x squared using the first principle method. Now example 3, we find the derivative. So gradient function, so many names can be used: derivative, gradient function, all that. So we find the derivative of y equals to 1 over x cubed. What we need to do here is to rewrite this one in the form y equals to x into power negative 3, as we learned in form 2 in the topic indices. So after writing that, we know that a small change, if we take a small change in x, like I said, to be a small change in x to be h, and therefore that means our y2 becomes x plus h into power of negative 3, and we know our y1 is x into power of negative 3, and our x2 is x plus h, and x1 is just x. So like we have done here, you subtract. We need again to expand this. What we do, let's deal with the numerator first. We deal with the numerator first before we go to the denominator. If we deal with the numerator, we need to, you can expand this, but because of the negative, it will be difficult. We need to take it back again to using indices to the original form. So x plus h into power of negative 3 becomes 1 over x plus h power of 3, and minus this becomes 1 over x power 3. Now you expand this separately, then you minus 1 over x cubed. Expanding this one becomes x cubed plus 3x squared h plus 3xh squared plus h cubed. So 1 over that minus 1 over x cubed. There is, you find the LCM, this times this one, this times this one as the LCM. So this comes to the whole thing, x cubed times. So we shall have x cubed times 1, which gives you x cubed minus, you have a bracket there, minus x cubed comes with the whole thing these times. So we multiply 1 into the whole of that, the whole of this. That is x cubed plus 3x squared h plus 3xh squared plus h cubed. We close the bracket. Now, if you open the bracket, that is, you open the bracket, it will be x minus x cubed. This becomes, this minus changes all these pluses into negatives. So it will be x cubed minus x cubed, because there is an x cubed here. That's x cubed minus 3x squared h minus 3x h squared minus h cubed. All these becomes negatives. Then all over x, this one multiplies, it becomes x power 6. It comes here x power 5, here x power 4, and x cubed here. So we shall have x power 6 plus 3x power 5h plus 3x power 4 h squared plus x cubed h cubed. That is our numerator. If you work on the denominator, x plus h minus x, remember x plus h minus x, the x and x goes because x minus x is 0 and we remain with an h. That is our denominator. And therefore, the numerator we divide by the denominator, h all over 1. This will is the same as remember x and x goes, we remain, it is 0 now, we remain with the negative 3. So it is the same as negative 3x squared all over this times 1 over h, which is equal to, or this, we factor this out with an h is common, it remains negative 3x squared minus 3xh minus h squared into brackets h all over x, all that times 1 over h. 1 over h and h cancels out. So we shall remain with negative 3x squared minus 3xh minus h squared all over x power 6 plus 3x power 5h plus 3x power 4 h squared plus x cubed h cubed. And when h intends to 0, we shall have, remember, where we have now an h, we put a 0. It will be 0 here, 0. So we shall remain with this one, negative 3x squared all over all these. There is h here, it becomes 0. It remains x power 6. Now, this one can cancel out. X comes to x power 6, x power 4 times. So x comes here, x power 4 times. So we shall remain with negative 3 all over x power 4. So that is our gradient, or that is our gradient function, dy all over dx becomes negative 3 all over x power 4. Somebody can write this as negative 3 x power negative 4. Negative 3x power negative 4 is still the same thing. Now, gradient function of polynomials. That's a polynomial is an expression with terms that have different powers of x. An example is that we find the gradient function of y equals to 3x squared minus 12x plus 8 by using the first principle method. Now, the coordinates, remember, becomes still x plus, that is our y2 becomes x plus h squared. If we are dealing with the power, this is the highest power. If it was power 3, it becomes x plus h cubed. It was power 4, x plus h power 4. Now, in this case, our y2 becomes x plus h squared, and of course, our y1, all these takes our y1. Now, we will have 3, where we have an x, we put x plus h, we square, minus 12 into x plus h, because x is x plus h, plus 8. Then we minus this one original as our y1, all over x plus h minus x. Now what you do, this one x plus h squared, you expand it, you'll get as x squared plus 2xh plus h squared. And then you also open this bracket, becomes minus, this becomes negative, so it is minus 12x minus h, which is minus 12x minus 12h, then plus 8, then minus, still you retain the bracket because this negative will change, minus. Now this is 3x squared minus 12x plus 8, all over that. So this becomes, if we open this bracket, this will be plus 12x, and this becomes minus 8. That becomes minus 8. So we shall have 3x squared plus 6sh plus 3h squared minus 12x minus 12h plus 8 minus 3x squared plus 12x minus, because plus this is negative and this becomes plus, and this becomes negative, minus 8, or x plus h minus x. Now this one, if we have some like terms, if there are, like 3x squared and 3x squared will cancel out, and then we shall also have 12x and 12x. This is negative and this is positive. It also cancels out. Negative 12x plus 12x is 0. So we shall also have 3h squared remains. 12x, we have said it will cancel. Yeah, 8 and 8 cancels. It becomes a 0. So we shall remain with 6xh plus 3h squared minus 12h, because the others shall have cancelled out, all over this x and the x goes will remain with h all over h, so we shall have it here. This one we factor the numerator. If we factor the numerator with h, we shall have 6x plus 3h minus 12 into h all over h. H and h cancels, so it remains 6x plus 3h minus 12. And therefore, as h tends to 0, we shall have, where we have an h we put as 0, we shall have 6x minus 12. 6x minus 12. So that becomes the derivative using the first principle method, or in simple terms, the gradient function. Now, you further attempt the following questions for your own benefit. Using the first principle method, do all these 3 questions for your own understanding, for the better understanding of this. Now, let's talk about gradient function of a curve by applying dy over dx. Now, from dy over dx is usually used in differentiating of a function instead of using the first principle. From the previous workings, like y equals to x cubed, and the one y equals to x cubed, dy over dx we found it to be 3x squared. So if you consider here what has happened to the numerator, and there is a coefficient here, you realize that the numerator, that is the power, the power comes to be the coefficient of x. It multiplies with the coefficient of x, and the power reduces by 1. Consider this other case, y equals to 3x squared minus 12x plus 8 becomes 6x minus 12. So you'll be able to realize also that the power multiplies with the coefficient of x becomes 6, and also the power reduces by 1 to become x power 1, which is the same as x. And then here 12, the power is 1, multiplies with 12 becomes 12, and the power reduces by 1 to become 0. Anything power 0 is 1, so we remain with 12. So that is why we get dy over dx to be 6x minus 12. So that means the constant, this is a constant, you differentiate the constant, becomes 0. So we shall have observed that the power of x is multiplied by the coefficient, as I've said, and at the same time the power reduces by 1. And therefore, the general formula for a general function y equals to kx power n will be given by dy over dx as kn x power n minus 1. This becomes now the formula. Now, the derivative of n constant is 0. Like constant here, the derivative of 8 is 0. That is what we have observed. And then we realize that the dy over dx can be called as gradient function, can also be called as derivative, can also be called derived function, or somebody can call it differential coefficient. So in any case you find n of this name being used, remember it's asking the same thing, that you find the gradient function or you find the derivative. N name used among these names will remain the same. Now, we want to do an example that we find the derived function of each of the following. If you are given s equals to t cubed minus 3t squared plus 4t, the solution is ds. It's not always dy over dx. Now we are using letter s and t, and therefore we shall write ds all over dt, ds all over dt equals to this times this one, like we said, it becomes 6t, and the power reduces by 1, 3 minus 1, it becomes 6t squared minus, this is 3 times 2, which is also 6t, the power reduces by 1, which becomes 60 power 1, which is the same as t, so it is 6t. Then plus power here is 1 times 4 becomes 4, the power 1 minus 1 becomes 0, n number or anything raised to power 0 is 1, so 1 times 4 becomes 4, so we shall have ds over dt as 6t squared minus 6t plus 4. But b, we also find the derivative of a equals to v squared minus 2v plus 10. Now, in this case, we shall talk about dA over dV. dA over dV. So dA over dV becomes this one, 2 times 1, it is 2, and the v, remember, 2 minus 1 is 1, so it is v power 1, which is the same as v. So it will be 2v minus, this is v power 1, 1 times 2 is 2, 1 minus 1 is 0, v power 0 becomes 1, 1 times 2 is 2. So we shall have 2v minus 2, and the derivative of n constant, we say it is 0, so plus 0, which is the same as 2v minus 2. If you have a question like this one, y equals to x power 4 minus 2x cubed plus 3x squared plus 2x plus 5 all over x cubed. Now we want to differentiate this. We want to find the derivative of this. The first thing you do is that you divide all this by the numerator by x cubed. Each of the part of the numerator, you divide it by x cubed. So we shall have x power 4 over x cubed minus 2x cubed all over x cubed plus 3x squared all over x cubed plus 2x all over x cubed plus 5 all over x cubed. Now you realize this one, x cubed comes here x times, so we shall have x minus x cubed cancels, so it is minus 2 plus x cubed, this one becomes cancels, we remain with x here, can be raised upwards to be 3x power negative 1, that is 3x power negative 1 plus this one x comes here, x squared can be raised up to be 2x power negative 2, that is plus 2x power negative 2, then plus this one can be raised to be 5x power negative 3, which implies that now if we differentiate using the normal, this becomes 1. We said it has a power of 1. 1 times here, times 1 becomes 1. 1 minus 1 is 0, so x power 0 is 1 times 1, which is 1. So we shall have a 1 minus, this a constant is 0, so it's minus 0 plus this one 3 x power negative 1. Negative 1 times 3, it becomes negative 3, so it will be minus 3. Negative 1 minus 1, it becomes negative 2, so it will be minus 3 x power negative 2, then minus, the reason for a minus is because negative 2 times 2, it becomes negative 4. Negative 4, remember we have negative 2, the power now becomes negative 2 minus 1, which is negative 3. So we shall have negative 4, that is minus 4, x power negative 3. Then this one, also it's a minus because of negative 3 times 5 becomes negative 15. And negative 3, the power now becomes negative 3 minus 1, which is negative 4. So it will be minus 15 x power negative 4. So that will become our dy dx. Dy dx of this. So you must be keen on such questions. If you are given such, should we know how to go about them. The 0, remember we have said that the 0 goes, the 0 is insignificant in this case, so we shall have 1 minus 3x power negative 2 minus 4x power negative 3 minus 15x power negative 4 as our derivative. Now, another question, you are given y equals to x squared plus 4x plus 4 all over x plus 2. You have to think on how to go about this one. When you look at the numerator here, this is 4 and this is x squared. You realize this is a perfect square. Being a perfect square, you think on how to factorize. Or in simple terms, you can easily factorize this one. Just factorize. If you factorize the numerator, it will be x plus 2 into x plus 2 is the same as this one. Because if you expand this, you get still this one. All over x plus 1 like it was. So you realize x plus 2 and x, you can cancel one of them. X plus 2 and x plus 2. So we shall remain with x plus 2. So we differentiate dy over dx of x plus 2. dy over dx of x plus 2, remember 2 is a constant, is 0. The differential of a constant differential, if you differentiate a constant, you get 0. So differentiate this one. There is a power of 1 times 1, it becomes 1. And then the power of 1 minus 1 is 0. X power 0 becomes 1. 1 times 1 is 1. So dy over dx of x plus 2 is 1. So this is the differential function of x squared plus 4x plus 4 over x plus 2. Simple as that. You factorize first and then you are able to finish. Let's talk about gradient of a curve at a point. How to find gradient of a curve at a point. To find gradient at a point of a curve, we take the following steps. First of all, you find the gradient function or the derivative, then substitute the x coordinate for x in the gradient function, and then the results are the gradient of that given point. Example, find the gradient of the following at a given point. A, we have y equals to x squared at a point 1, 2. So the first step we have said is to find the dy over dx. dy over dx of this becomes 2, that is 2 times this one is 2, and x 2 minus 1 is 1, so it becomes 2x. dy over dx of this one becomes 2x. And then we know the given point is 1, 4. So when x is 1, then dy over dx will be, we substitute whenever there is an x with 1. 1 times 2 is 2. dy over dx becomes 2. And that is the gradient of the curve at that given point, at the point 1, 4. That is the gradient. Part B, we find the gradient of y equals to brackets x squared plus x into brackets x squared minus 1 all over x plus 1 bracket squared at the point 2, 4. Remember, we need to find the derivative of this. That's dy over dx. What we do first is to look at this one. If you look at this one is difference of two squares. Difference of two squares we learned in Form 2. If you remember, a plus x into a plus b into a minus b is the same as a squared minus b squared. So you apply the same principle here. You will get this one as x plus 1 into x minus 1. If you expand x plus 1 into x minus 1, you will get x squared minus 1. So we get that one. And this one, remember, just is a square. Write it as a square. That is x plus 1 into x plus 1 is the same as x plus 1 squared. So you write it that way. And this one, you can open this, you can factor out and have x into x plus 1. So we shall have x into x plus 1 into x plus 1 x minus 1. Like I've said, all over x plus 1 into x plus 1. So whenever we have x plus 1, like this x plus 1 cancels with this one, and x plus 1 cancels with this one. So we shall remain with x into x minus 1, x into x minus 1, which becomes x squared minus x squared minus x. Now we are able to differentiate this one. If you differentiate this one, it becomes 2x, because 2 minus 1 is 1, so we shall have 2x minus 1. 2x minus 1. We shall have 2x minus 1 at 0.24. So that means x is 2. Whatever we have an x, we put 2. So 2 times 2 is 4 minus 1 is 3. So the gradient at this point is 3. 4 minus 1, which is 3. Now let's talk about equation of a tangent to the curve. How to find equation of a tangent to a curve. To find equation of a tangent to a curve, we first of all need to know that a tangent to a curve is a straight line that touches the curve at one point. A straight line that touches a curve at one point is what we call a tangent. Now it can also be called a parallel. A parallel. That means the gradient of the tangent at that certain point is the same as the gradient of that curve at that point. The gradient of that curve at that point and the gradient of the line will be equal. That is when we talk about parallelism, if you remember our Form 2 work. So the gradient function of the equation given, the gradient function of the equation given is first calculated. That is, you first calculate the equation, the gradient function of the equation given. You first calculate that one. Then the x-coordinate is substituted in the gradient function to obtain the gradient at that point. Then we apply the relationship, that's m1 equals to m2 for parallel lines, like we have explained, and then to find the gradient of the tangent at that point. Then using the gradient found and the coordinate given, the equation of the tangent can now be calculated. Where a situation where we have only one coordinate given, let's say x or y coordinate is given, the other coordinate should be substituted to the equation given of the curve to obtain the other coordinate. Let's do some examples. Example number 1. We find the equation of the tangent to the curve y equals to 6x squared minus x minus 4 at the point x equals to 1. Now our solution is that if we take this equation and we have only one point given, we need to get the coordinate, and to get the coordinate we bring this one point, we substitute in the equation given to find the value of y. So 1 we substitute here, we shall have 1 times 1 squared is 1 times 6, we shall have 6 minus 1 minus 4, 6 minus 1 minus 4. So 6 minus 1 you get is 5, 5 minus 4 you get is 1. So the coordinate becomes 1, 1. So that is our coordinate, and this is what we shall use at that point to find the equation of the tangent. Now we need to find the dy dx of this, because this is a curve, and the curve at that given point, the gradient of the curve at that given point equals to the gradient of the tangent. So we shall have dy over dx as 12, this 6 times 2 is 12x minus 1, this is 0. So we shall have 12x minus 1, and now when x is 1, we shall have our gradient as 1 times 12 is 12 minus 1 as 11. So the gradient of at that point of the line of the curve is 11, and the gradient of the curve at that point equals the gradient of the tangent, which is also 11. So we use 11 as our gradient for the tangent, and then we shall have 11 over 1 which is equal to, we take our other point as xy, which is equal to y minus 1 all over x minus 1. So we cross multiply. We shall have 1 into brackets y minus 1, which becomes y minus 1 equals to 11 into brackets this, you open it, will be 11x minus 11. So y minus 1 equals to 11x minus 11. That implies that y, if we remain with y on our left hand side, we shall have y equals to 11x minus 10, because negative 1 becomes here, it is now negative 10 plus negative 11 plus 1, it's negative 10. So we shall have y equals to 11x minus 10 as the equation of the tangent, as the equation of the tangent. Now the gradient of the curve y equals to 2x cubed minus 9x squared plus px minus 1 at x equals to 4 is that 6. So we are given the gradient of the curve. Gradient of the curve is what we are given, and this is the equation of the curve at a point where x is equals to 4. The gradient is that one. Remember, to find the gradients is dy over dx of this equation. Dy over dx of this equation. Now we can find the dy over dx of this equation. It is going to be 6x squared minus 18x plus p, and this is 0. So we shall have dy over dx is x squared minus 18x plus p. And when x is 4, because we are told x is 4, we substitute wherever we have an x as 4, it will be 4 squared times 6, 6 times 4 squared minus 18 times 4 plus p equals to 36. So we shall have 96, this is 96 minus 72 plus p equals to 36. 96 minus 72 plus p equals to 36. 96 minus 72 becomes 24 plus p equals to 36. So p equals to 36 minus, if we take this other side, it will be 36 minus 24, which is 12. So our p is 12. And then we are supposed to find now, remember the question part b, the equation is now, the equation becomes 2x cubed minus 9x squared plus 12x minus 1. Instead of p, we put now 12. So the part b, we find the equation of the tangent to the curve at x is equals to 0.5. Now at the point x equals to 0.5, we find the equation of the tangent. Now what we need to know is that at x equals to 5, we need to find the coordinate. So to find the coordinate, we substitute 0.5 in our original equation, in this equation, in the equation of the curve, to find the coordinate of that point. So it will be 0.5 cubed times 2, 0.5 cubed times 2 minus 9 times 0.5 squared plus 12 times 0.5 minus 1, all that gives you 3. So the coordinate becomes 0.5 and 3. That's the coordinate of the curve at the point x equals to 0.5. Now we find the dy over dx, dy over dx of the equation of dy over dx of this, dy over dx of this equation, we had found it to be x squared minus 18x plus p, and p is 12. So it is 6 squared minus 18x plus 12. That is the dy over dx. That's the gradient. And we know the gradient at that point, which is where x is 0.5, is the same as the gradient of the tangent that passes through that point. Now, we substitute 0.5 with x to find our gradient. So 0.5 squared times 6 minus 18 times 0.5 plus 12, it gives you 4.5. So our gradient at that point where x is 0.5 is 4.5, which we can write it as 9 over 2. 9 over 2 is 4.5. We write in fraction form for easy manipulation. So we shall have 9 over 2, which is equal to, we take another point xy, which is equal to y. Now we use this coordinate y minus 3 all over x minus 0.5. Now, we open the bracket. This becomes 9x. This we open 9 into, we cross multiply, so we shall have 9 into x minus 0.5, which gives you 9x minus, this is 9 times 0.5. Remember, this is the same as a half. A half times 9 is 4.5. So 4.5 we said can be written as 9 over 2. So we shall have 9x minus 9 over 2. 9x minus 9 over 2, which is equal to this one. It is 2y minus 6. 2y minus 6. Now let's have the like terms together. So not like terms in this case, but we shall have 18. That is if I multiply by 2 or each part by 2, so that I remove the fraction. So I shall have 18x minus 9 equals to 4y minus 12. 18x minus 9 equals to 4y minus 12 by multiplying by 2 or through. So I shall have 18x minus, if I take 4y this other side, 18x minus 4y equals to negative 3. That is the equation. Or somebody can write it as 4y minus 18x equals to 3 if you want to remove the negative. So that is the equation of the tangent to the curve. Now we find how to find the equation of a normal. Equation of normals. Normals, they are also called perpendiculars because these are perpendicular lines to the tangents. A normal to the curve at a given point is a line perpendicular to at that point. Is a line perpendicular at that point. Therefore, we apply the relationship m1 times m2 equals to negative 1 for perpendicular lines that we learned in Form 2 for us to be able to find the gradient of the normal. Now, whereby m1 we know is the gradient of the tangent, will be the gradient of the tangent line, and m2 will be the gradient of the normal line. M1 gradient of the tangent line and M2 gradient of the normal line. The normal line is that line which is perpendicular to that tangent at that point. So when we are finding the equation of the normal, first thing we need to do is to calculate the gradient function of equation of the curve, gradient function of the equation of the curve. Then we substitute. Remember, the gradient of the equation of the curve, the gradient of the curve of the equation of the curve will be the same as the gradient of the tangent at that point. So we substitute x coordinate in the gradient function to obtain the gradient at that point. And applying m1 and m2 equals to negative 1, we shall be able to calculate now the gradient of the normal line. Then the equation of the normal line can therefore be found using the gradient and the coordinates where it is passing. As we said from above, that where you have only one coordinate given, the first thing you do is you substitute in the equation of the curve to obtain the other coordinates. Now, an example is that we find the equation of a normal to the curve y equals to x cubed minus 2x minus 1 at 1, negative 2. So you are given the 2 points, 1, negative 2. Now, what we do, we find the gradient function of this, and then we substitute with x1 to find the gradient of the curve at that point, which is the same as the gradient of the tangent that is passing through that point. And then the gradient function here becomes dy over dx equals to 3x squared minus 2. 3x squared minus 2. At point 1, 2, now the gradient here we substitute with 1, it will be 1 times 3, which is 3 minus 2 is 1. That is the gradient of the tangent line is 1 from 3 minus 2, which gives you 1. So, and therefore, gradient of the normal would be, if we call m1, we are now looking for the normal m2. m2 times 1 equals to negative 1. So our m2 becomes 1 over negative 1 over 1, which gives you negative 1. that is the gradient of the normal now becomes negative 1. So we shall have, we use this same coordinate, we shall have y minus 2 all over x minus 1 equals to negative 1 over 1. So we cross multiply 1 into that, so we shall have, remember, minus becomes positive, so we shall have y plus 2 all over x minus 1 into equals to negative 1. Cross multiply, we have said it will be y plus 2, because times 1, if you open the bracket, still remains y plus 2 equals to negative 1 times x becomes negative x, negative 1 times negative 1 becomes positive 1, so it will be negative x plus 1. So y plus 2 equals to negative x plus 1. So the equation will be, if you take 2 this other side, it will be y equals to negative x plus minus 1, because this is 2 positive, it comes here, it becomes negative 1 minus 2 is negative 1. So we shall have negative x minus 1 as the equation of the normal to the curve. Equation of the normal to the curve at the point 1, negative 2 becomes y equals to negative x minus 1. Example number 2 is that we find the equation of the normal to the curve y equals to 4x squared minus x minus 3 at the point where x equals to 2. At a point where x equals to 2. Remember, here you don't have the coordinate. So the first thing to do is to find the coordinate. And for us to find the coordinate, we substitute x in the equation to find the value of y. So if you substitute x here, it will be 2 squared times 4, 2 squared times 4 minus 2 minus 3. Minus 2 minus 3, which becomes 16 minus 2 minus 3, which is equal to 11. So the coordinate becomes 2, 11. And the next step, like I gave you the procedure, is we find the dy dx of the equation. Dy dx of this becomes 8x minus 1. It becomes 8x minus 1. And therefore, we are able to find the gradient of the curve at the point which is equal to the gradient of the tangent, which will be, we substitute our x2 here, we substitute here, it becomes 16 minus 1, it becomes 16 minus 1, which is 15. So the gradient at that point is 15, that's the gradient of the tangent. And we know m1 times m2 equals to negative 1, so to get our m2 now, because 15 times m2 equals to negative 1, m2 now will be negative 1 divided by 15. So if we use the same gradient that we have found for the normal, negative 1 all over 15 will be equal to y with these coordinates, y minus 11 all over x minus 2. We cross multiply, it will be 15 into y minus 11. 15 into y minus 11 becomes 15y minus 165 equals to negative x plus, because negative and the negative becomes positive, negative x plus 2, which is equal to 15y. If we take 165 this other side, it will be 165 this other side, and we bring x this other side, it will be 165, it becomes positive in this other side, plus 2, it will be 167, and the x becomes positive on our left hand side. So we shall have, we take x this other side, we shall have 15y plus x equals to 167. That becomes our equation. Or if you want to have it in the form y is equals to mx plus c, you can rearrange that. Now I want to leave you with a question that you should be able to do at your own time, that you find the equation of a normal to the curve h equals to 6p cubed minus 2p, where p equals to 2. That is the end for now, and remember to subscribe for you to get our next subtopics on the same topic, differentiation, to know when I upload, which I'm uploading very soon. That is stationary points. I shall talk about nature of the turning point. I shall talk about curve sketching. I shall also talk about application of differentiation in kinematics. And finally, I shall talk about application of differentiation in maxima and minima. So be ready for that one before the end of this week. Thank you for listening to me, and may God bless you.